Alright, my name is Zachary Bush. The date is June 12th. June 10th, 2023. Here's my name, my student ID number, and my course ID. I'm doing a video on staining, bacterial morphology and staining, and I'm starting off. This experiment was fairly simple. I was able to get it done relatively easily. My biggest problem was that when I tried to drop like crystal violet onto the slide and let it sit, it wouldn't latch on to the sample. So then when I tried to like dab some of it off or to like rinse it off, everything would go and there would be nothing. It'd just be totally blank as if there was nothing on there in the beginning. So I kind of had to let it sit for way longer than it told me to, but that was the way I got it to work. Um, Ultimately, I think it turned out decent, but it's a bit of a bummer that it didn't go directly according to plan. But I guess I was able to make it work. I was able to get um, the colors of the cells and stuff like that. But let me get into it. I'm gonna use my phone for pictures. So let me pull up the first one. First one is the direct stain. So right here I have a direct stain. Let me turn off this light. Direct stain. And as you can see here, it's all colored violet. And direct staining is basically where you just drop the stain on there, let it sit for a minute, and then rinse off the stain, and then whatever's left, hopefully the stain kind of like latches onto the sample, and it will show when you put it on a microscope. It's much easier to see because the sample is now stained. Now, sorry, something came up in my throat. Moving on to the negative stain, right here. So the negative stain right here is that you see kind of clearly. Yeah, so the negative stain just adds a couple more steps. You add some more stains to it, and ultimately the negative stain, the goal of the negative stain is to stain just the sample and not anything around it. The stain I talked about previously, it has a tendency to stain other things around the sample, staining the surface, and the purpose of the negative stain is to only stain the sample. Moving on to the gram stains. Right here I've got my SE, and as you can see it's purple, as it is supposed to be. That means it is gram positive, which is correct. And yeah, so the purpose of gram staining is to determine whether a bacteria or fungus is gram positive or negative. Depending on that, really depends on the cell structure of the bacteria or fungus or whatever other sample you're using. If a sample is gram positive, for instance, it is much more susceptible to antibiotics because its thick cell wall will absorb the antibiotics, which kills it. So that's one important distinction, and it's something that's very important for life experience. So for example, if I was to get a sample and look at it and think like, okay, how can I quickly treat someone? And I get a sample, I look at it, I stain it, and I found out it is gram positive. I can say, okay, antibiotics will work very, very well on this particular bacteria or fungus. I'll prescribe antibiotics. So in that way, it's very, very useful for real life purposes. Moving on to the yeast. So it's a little more difficult to see. But basically, yeah, it's little tiny dots, and they are purple as well, meaning they are gram-positive, which I looked up is correct. And so far everything's going according to plan. Thumbs up. Ultimately, everything went good for this section of the experiment. But when it came to the E. coli, not so much. So pulling up the E. coli right now. Bam. So the E. coli, as you can see, is very clearly purple, and it is not supposed to be that way. So E. coli is gram-negative. How it became, or it didn't become gram-positive, but how the stain ended up becoming testing as gram-positive, I don't really understand why. That result is definitely wrong, and I'm not sure why it occurred. I performed everything as it should, but I guess you could just chalk it up to one of those things like something went wrong in the lab, and I don't know what. That just doesn't feel satisfying to just be like, well, it went wrong. But I've got no real answers to why. I went through the exact same procedure for all of them, and all of them tested positive. The two that were supposed to test positive tested positive, and the one that was not supposed to test positive tested positive. So I really have no idea as to why the E. coli tested positive. I've thought back on it, and there's nothing that should have stood out as kind of like, that looks a little off. Maybe I should check that out. Maybe I should do this to make sure that it doesn't test positive. I really have no solution to it, but yeah, I'm hoping that in future experiments something like this doesn't occur. But overall, I think the experiment went well. Overall, I think I was able to understand the content fairly well. And yeah, I will say this about the gram staining. So the purpose of the gram staining and how it works though. So if a cell is gram positive, it's because it has the thick walls. It has a much thicker wall compared to gram negative. And so what happens is as you're dripping on all these different stains, the the thicker cell-walled gram-positive samples, they soak up that stain. So it stays purple because of that. And that's why gram-positive is purple. Gram-negative, as you keep adding on these stains, the cell walls do not absorb the color of the stain, and it can just wash out. So as you put one on, washes out, and then the color of the last stain is red, so obviously the color of the gram-negative material would be red. So yeah, this is my video on staining, and hopefully it lives up to the standard. Thank you.